All right, today we're going to tackle one of the most fundamental ideas in all of programming, loops. We're going to see how Python can take the most boring, repetitive work you can imagine and turn it into an automated superpower. We've all been there, right? That feeling of copying and pasting, renaming 100 files one by one, or manually ticking items off a huge list. It's just draining. But what if I told you that in the world of code, that exact feeling of repetition is actually where you get a massive advantage? That's right. Loops are programming's answer to all that tedious work. They are built to do that stuff for you, flawlessly and at a speed you could never match. Seriously, think of it as your own personal robot, turning you from a tired worker into a programming superhero. It really is all about working smarter, not harder. So before we get into the nuts and bolts of how to write loops, let's take a quick second to understand why they are so incredibly important. It all comes down to a core programming concept. You know, normally a computer just reads your code like a book, starts at the top, reads to the bottom, and it's done. But what if you don't want that? Loops are a huge part of what we call control flow, which is just a fancy way of saying you get to control the order things happen. You can point to a block of code and tell the computer, hey, see this part? Run it again, and again, and again. Now in Python, you've got two main tools for this job. You can think of them like two different kinds of specialists. And knowing which one to pick for the situation, well, that's the key to writing really clean and efficient code. Okay, so on one hand, we have the for loop. This thing is perfect when you have a collection of items, like a list of names or a range of numbers, and you want to do something to each and every one. It knows exactly how many times it's going to run from the start. It's just like going through a checklist. On the other hand, you've got the while loop. This one's for when you don't know how many times you need to repeat. It just keeps on going as long as a certain condition is true. It's kind of like waiting at a traffic light. It's going to stay red until something happens to change it to green. Let's start with the for loop, because honestly, this is the one you're probably going to use like 90% of the time. It is the absolute workhorse of looping in Python. And the syntax, it's beautifully simple. You just say for some temporary variable in whatever sequence you want to go through. That colon at the end and the indented block of code underneath are super important. That indentation is how Python knows exactly what code is inside the loop. Let's see it in action. Let's say we have this list of fruits. The for loop is going to go through this list one item at a time, and it'll temporarily store each one in that variable we decided to call fruit. So first time through, it grabs apple from the list and prints it. Then it automatically moves on, grabs banana, and prints that out. And finally, it gets to the last item, cherry, and prints it. As soon as it hits the end of the list, the loop just stops itself. Simple, clean, totally automatic. But what if you don't have a list? What if you just want to do something exactly 5 times? Well, for that, we use the range function. You can think of range 5 as this little machine that instantly generates a sequence of numbers for you, 0, 1, 2, 3, 4, making it the perfect partner for a for loop. Okay, let's switch gears and talk about our other tool, the while loop. This is your go-to when you're not just going through a list, but instead you're waiting for some specific condition to change. The syntax here is just while some condition is true, then do the code inside. So in this example, we start a counter at 0. The loop checks, is count less than 5? Yep, 0 is less than 5. So it prints the count, and then, and this is the most critical part, it increases the count by 1. Then it zips right back to the top and checks the condition all over again. It'll keep doing this until count is no longer less than 5. So you might be asking, what happens if you forget that count plus equals 1 line? Well, count would stay at 0, forever. The condition count less than 5 would always be true, and your loop would run endlessly. This is what we call an infinite loop, and it's the number one thing you have to watch out for when you're using while loops. All right, now that you've got the basics down, let's look at some power-ups. Python gives you these special commands to fine-tune your loop's behavior right from the inside. First up, we have break and continue. Think of break as your emergency exit. The second your code hits a break statement, the loop just stops dead in its tracks no matter what. It's perfect for when you're searching for something and you found it, no need to keep looking, right? Now, continue is different. It doesn't stop the whole loop. It just says skip the rest of the code for this current item and jumps right back to the top to start the next one. You use it when you want to ignore a specific case. Now here's a really cool Python trick that a lot of people don't know about. You can actually add an else block to a loop. So imagine 2 paths, one where the loop finishes its entire run and one where it's cut short by a break. That else block, It will only run if the loop finishes naturally, without ever hitting a break. This is awesome for things like adding a not found message if a search loop comes up empty.
Okay, theory is great and all, but let's see how these loops are used in some common, everyday programming patterns. This is where these ideas really start to click.
A classic example is summing up a list of numbers. The pattern is pretty much always the same. First, you create a variable to hold your result, like total equals 0. Second, you loop through your list of numbers. And third, inside the loop, you just update your total with each number you come across. It's a simple but super powerful pattern you are going to use all the time.
And another powerful pattern is the nested loop. That's a loop inside another loop. This is your go-to tool for working with anything that looks like a grid or a table. Just look at the slide. The outer loop, I, is handling the rows. Now, for each single row, the inner loop, J, runs its entire course to handle all the columns in that row. This is how you make sure you visit every single cell one by one.
All right, let's do a quick recap of the tools you've got now. The big idea is to automate repetition, right? So for known sequences like a list or a string, you're going to grab a for loop. If you're waiting for some condition to change, a while loop is your best friend. And don't forget, you can fine-tune both of them with break and continue to handle pretty much any situation. So, we've taken this idea of being stuck in a loop, and we've turned it into a genuine programming superpower. You now have the tools to make the computer handle all the boring grunt work. The only question left is, what are you going to build with this power? Thanks for joining me.